Xanadu is developing photonic chips for near-term quantum computers. These X-series chips are made out of silicon and silicon nitride and consist of three primary modules: squeezers, the input to the computer, an interferometer, the logical gates, and photon detectors, the measurement output. Let's look at each in more detail. Classical laser light is first distributed to an array of squeezers. These microscopic devices are made of small ring resonators, which, when driven by bright classical laser pulses, generate a special quantum state of light called a squeezed state, Xanadu's version of a qubit. These states involve a quantum superposition of different numbers of photons, and, once generated, are coupled into an array of bus waveguides, which carry them to the next stage. The squeezed states now enter a network of beam splitters and phase shifters called an interferometer. To program the interferometer, the user's instructions are loaded into the chip electronically. The control system translates these instructions into a set of electrical voltages that are applied to the different components on the chip. The squeeze states interact with one another and are entangled, a prerequisite for quantum computing. The interferometer can be thought of as a sequence of quantum gates acting on the inputs. In general, the output of the interferometer is a highly entangled quantum state encoding the processed quantum information. The quantum state is now ready for readout. Each output of the chip is directed to a special photon detector called a transition edge sensor. These detectors count how many photons are present in each output, yielding an array of integers that are reported back to the user. The results of the computation or algorithm are encoded in the statistics of this photon number data. The Xanadu X-series chips are useful for solving complex problems in the domain of graph theory that are relevant for finance, chemistry, and logistics. And it's all available on the Xanadu Quantum Cloud.